Good afternoon, everybody, all students and teachers who are listening to this webinar. I welcome you all. Today my target will be to get you interested in a subject called physics, to feel the thrill of physics, to know how beautiful subject it is. Once you start loving physics, you will work hard on it and you will definitely master it. In the end, I will try to give you some practical tips regarding JEE exam, how to prepare for it as well as how to behave inside the exam hall. But initially, I will try to make you love this subject called physics. If I am able to do that, I will consider myself successful. The modern science began in 17th century. Before that, human brain has been intrigued by questions like why sky is blue, why sunset is red, what are rainbows, what exactly is light, what exactly is sound, why there are waves in ocean. All such questions have haunted human mind since thousands of years. But a real scientific way of looking at them, a real scientific study started in 17th century only. So whatever we know today is a knowledge acquired in last 400 years or so. But let me tell you, in 400 years, we have acquired a lot of knowledge, but even more still requires to be uncovered. Even more is required to be learned. So there is tremendous scope, for all of you who want to pursue this subject as a career. What does a physicist actually do? A physicist systematically studies nature. If required, he does some experimentation, and if required, he does some mathematical modeling also. His ultimate aim is to frame a law, a rule which can explain many diverse natural phenomena. What exactly is a law in physics? I can explain it to you like this. Suppose two of you are masters in chess and you are playing chess. I am a novice. I have never heard about this game. I know nothing about chess. While you play chess, I watch you. You don't answer any of my questions, but you let me watch your game. So I keep on watching for hours together, maybe days. I keep on watching two of you playing chess. What will I learn? Literally nothing. I will never know what exactly you two people are doing. Why exactly you are making a particular move. I will never know that. But if I am a very careful observer, if at all I am a very careful observer and I have got a big brain, I may be able to pick out few rules of the game. I may be able to understand that a piece that is called bishop, it always moves diagonally. A bishop on red square, black square, always remains on black square, and the one that is on white square, it will always remain on white square. This is one rule of the game. A pawn always moves one step at a time. This is another rule of the game. Wherever chess is being played in this entire universe, these rules are never violated. Everybody plays the game according to set rules. Similarly, the great God is playing chess with all of us. He is making many moves at a given point of time. And all those moves, all those happenings, all those phenomena are guided by certain set of rules. These rules are known as laws in physics. But God is never going to give a phone call to you and tell you what these rules actually are. Great scientists like Newton and Einstein were extraordinarily brilliant. They observed the nature very carefully. If required, they experimented, and they were able to pick out few rules of the nature. Newton was able to pick out one rule, that any two massive universe attracts each other. So this rule, law of gravitation, was so important, is so useful that it can explain why a ball when left falls downward. It can explain why Earth goes around the sun. It can explain why moon goes around the earth. In fact, it can explain literally each and every movement of celestial heavenly objects. So Newton's law of gravitation, it is called a law because it is one rule of the nature that is followed everywhere. So whenever a physicist is able to figure out a rule that is being followed in nature, it becomes a law in physics. But a law is never permanent. Yes, you have heard it correctly. A law is never permanent. A law can change any moment, any day. Like after Einstein's theory of special relativity, Newtonian mechanics got challenged. In fact, if you have particles moving at very high speed, Newtonian mechanics fail. Similarly, our understanding of light has changed many a times in last 200 to 300 years. It is quite an interesting story. I'll take a little bit of time and try to tell you about that. Before the beginning of 19th century, everybody used to believe in Newton's theory of light. Newton said that light consists of small particles which he called corpuscles. Light consists of tiny particles which travel in a straight line in absence of any external force. Based on this hypothesis, he was able to successfully prove law of reflection. His contemporary Christian Huygens, used to believe that light is a wave phenomena, but nobody paid heed to him. Such was the authority of Newton at that point of time. But everything changed after year 1802. In year 1802, one young scientist named Thomas Young performed famous two-slit experiment, interference experiment, and the observations those were seen in that experiment could not be understood, could not be explained based on Newtonian theory. They could be explained only if one believed that light is a wave. So after 1802, light has become a wave. It is regarded as a wave. But there was one big problem with that theory also. People at that point of time knew that any wave requires medium for propagation. So light from a star or sun is reaching us. How come? There is no medium in between in the interstellar space. Still light manages to reach us starting from a distant star. So if light is a wave, how it can travel in vacuum? That was a big question. But if you don't consider light to be a wave, you will never understand that experiment of Thomas Young. So it was a big dilemma, and it was resolved somewhat 65 years later in year 1867. One genius named James Clerk Maxwell showed that light is an altogether different kind of wave. He maintained that light is a wave, but he said that it is different from other mechanical waves. He said that light is an electromagnetic wave, and he showed that it will not require any medium for propagation. In fact, Maxwell's contribution is too great. Maxwell wrote down 4 equations, and if anybody is able to learn those 4 equations, it is assumed that he knows everything in electricity, everything in magnetism, and of course he understands the nature of light. Such great was that invention that all physicists world over went on a holiday for next 30 to 35 years. No basic research work was done. After 1867, people started believing that everything has been discovered in physics. Such was the power of those 4 laws. Anyway, what I was telling you, that light, initially Newton believed that it is nothing but tiny particles moving in a straight line. Then after Thomas Young experiment, it became wave with a question mark, that how it can travel in empty space. Then Maxwell corrected it. It is a wave, it is a different kind of wave, it is a different kind of wave, and it will not require any medium for propagation. People started believing that, people started believing that physics is over. But that was not the case. In the beginning of 20th century, photoelectric experiment caught attention. One famous scientist, Leonard, performed a series of experiments on photoelectric effect, and the observations were startling. Nobody could explain what was actually happening. No theory in physics could explain the observations. Then came the great Albert Einstein. He was able to successfully explain all the observations after assuming that light consists of tiny energy lumps. Yes, Einstein was in a way saying that light consists of particles. If a beam of light hits you, it exerts force on you. Using an intense laser beam, you can move a light object. Yes, light exerts force, and light has a particle character. So Newton said light is a particle. Thomas Young experiment proved that light has to be a wave, but what kind of wave it was not known. In 1867, Maxwell said that light is an electromagnetic wave, and in 1905, Einstein is once again saying that light is particle. So our understanding of light got changed many times, and today we believe that light has dual character. At times, light behaves like a particles, a stream of particles, and at times it behaves like wave. So light has got dual character. That is what we understand today. What I was trying to tell you is, a law in physics is not permanent. Our understanding of nature is never permanent. Whatever law has been framed, it can get changed any day with a better law. And that is what physicist keeps on doing. Physics has got two entirely different worlds. Physics can deal with something as vast as universe, and it can at the same time deal with something as tiny as an electron. And let me tell you at the beginning itself that laws which govern these small particles are very different from laws which are applicable for macroscopic objects. That means laws which are followed by an electron in hydrogen atom is nothing like the laws that is followed by a car moving on a road, or law that is followed by a ball moving under gravity. Electron behaves really in a peculiar and strange manner. So physics is clearly segmented into two parts. There is a physics for large objects, and there is a physics for very tiny particles like electrons. Physics deals with something as vast as universe. How vast is the universe? I will try to make you realize that. First, let us talk about solar system. I say that solar system is huge. Do you know that no man-made object has ever crossed the boundary of our solar system, except for a spacecraft named Voyager 1. Voyager 1 was a spacecraft launched by NASA to photograph basically Jupiter, and after that it was allowed to freely wander in free space. One wise thing that scientists at that point of time did was to keep the electronic equipments in Voyager 1 functional. They powered it by some radioactive material, nuclear material. Nuclear or radioactive material, if you have 1 kg of uranium, it will never go to zero even after hundreds or thousands of years. They last forever, in simple language. So that particular spacecraft is still getting power by its own nuclear power plant, and it is still going away from us. It is believed that in year 2012 it crossed the boundary of solar system. So any man-made object has gone that far only. Most of the time we have seen in our junior class books, there is a nice diagram of solar system representing sun along with its planets. That diagram is quite misleading, let me tell you. It does not give you the feel of scale of how big the solar system actually is. I'll make you understand it like this. Suppose one fine day, God decides to compress the solar system uniformly from all sides. That means he decides to squeeze, to compress the sun. He decides to squeeze or compress all the planets. He decides to decrease all the distances, and that too uniformly. If he compresses the universe in such a way that Earth is reduced to the size of a peanut, then how far is the sun? But try to understand my question. If God decides to compress the entire solar system and he compresses it from all the sides in such a way that our Earth is reduced to the size of a peanut, then what do you think? How far is the sun in this particular solar system? Most of you must be thinking in terms of few centimeters, maybe a foot or two. But let me tell you, in this particular solar system, in which Earth has been reduced to size of a peanut, sun is at least 4 kilometers away from the Earth. Now imagine the vastness of our solar system. If Earth were of the size of a peanut, then sun will be at least 4 kilometers away from that Earth. Such huge is our solar system. And how big our solar system is in the context of the entire universe. Let me tell you, it is too small. It is too small. Consider yourself standing on a a small beach. The number of sand particles that you see around yourself, consider them to be stars, galaxies and planets. Now, among all those sand particles, among all those stars and planets, pick any one sand particle. This is your solar system. Yes, if universe is the entire beach, then any one sand particle represents the solar system. So how minuscule we all are in the context of the universe, it can be understood. From wherever you are sitting, you can walk 47 billion light years in every direction, and there is the edge of the universe. Actually, there is no edge of universe, but just to give you a feel of the size, I am saying that our universe extends up to 47 billion light years in every possible direction from wherever you are located right now. 47 billion light years means the amount of distance that light will travel through in 47 billion years. And let me tell you, light travels 3 lakh kilometers in 1 second. So you can imagine how much distance it will cover in 47 billion years. In our entire universe, there are 200 billion galaxies. 200 billion galaxies. Among those 200 billion galaxies, our own galaxy is known as Milky Way galaxy. And the nearest galaxy to us is Andromeda galaxy. There are such 200 billion galaxies, and each and every galaxy has 200 billion stars in them. So just imagine the size of the vastness of the universe. And our sun is nothing but just an average sized star. Just an average sized star. Truly, our universe is so vast that it is difficult to imagine, it is difficult to fathom the vastness just sitting inside our room. It is very difficult to judge the vastness. But I hope you get a feel that it is truly vast. It is truly vast. And our solar system is very small in the context of the entire universe. And for that matter, we do not even know whether there exists another universe beyond our own universe. There might be many more such universes. We have no idea. We do not know. Without ever visiting the sun, we know a lot about it. For example, we know that sun is 15 crore kilometers away from us. We know that its size is such that 10 lakh Earths would be fitted inside it. We know that it was born some 500 billion years ago, and it will still remain alive, it will still remain burning for next 5 billion years. The sun was born 5 billion years ago and it is still having a life of 5 billion years or so. One interesting thing, before sun dies eventually, it will ensure that we all are also dead. The temperature will get so high that none of us are going to survive. But okay, that is 5 billion years away, possibly. These data does not amaze me. They are of course fascinating. We know that the sun is a 3 into 10 to the power 26 watt bulb. It fascinates me. But the most fascinating thing is, how do we all know this? No man has ever visited sun, but we know that 10 lakh earth could be fitted inside a sun. We know that it is 10 to the power 26 watt bulb. This is really amazing. This is really amazing. And if you learn physics, you will know how we came to know about all these things. A physicist, community of physicists has made you know all these facts. Great facts, I would say. The universe is too vast. Our solar system is small. We know a lot about sun. We know a lot about galaxies. But how do we know all these things? There is no means of communication between us and a star. No way of communicating. How do we know all about these? There is only way of knowing. That is light. Yes. Light from a star or a sun reaches us. That is the only means of communication we are having. Just by analyzing that light which we are receiving from star or sun, we know so much about them. Just by analyzing light that we receive from star, we know so much about them. That is interesting. That must interest you. So study of light, nature of light is of utmost importance. Now, our main objective definitely is to gather as much light as possible coming from a star or sun. And the equipment that helps you in doing so is telescope. Telescope has helped us know so much. What exactly is a telescope? Understand it this way. Most of the people think that a telescope is something which can magnify objects. No, I'm sorry. Magnification is not the purpose when you are looking at a star. Even if you magnify it 100 times, you will not be able to understand what is there inside the star. It is so tiny from that far a distance. Magnification is not the purpose. The purpose is to see the star. Using unaided eye, naked eye, all we can see is around 6,000 stars. If you travel worldwide and keep tracking each and every star, you will nearly see 6,000 stars, that's all. But if you have small telescope, say 2-inch telescope, and you look at the sky, you will see millions of stars. Even a small telescope will make you see millions of stars. Yes, I'm right. If you can get hold of a telescope, see the night sky, and you will be amazed. Telescope is nothing but our big eye. Why do I call it a big eye? Consider a very distant star, very far away star. Light reaching from that star to us is actually very dim. It is like you have a 100-watt bulb and you are standing at a distance of 500 meters from it. You will receive almost no light from the bulb because you are standing at a vast distance. So a star is also at a very vast distance from us. Though it is a very big bulb, but still light reaching us is too little. It is so faint that when it enters through into our eye through our pupil, very less amount of light energy goes inside our eye. Our pupil has a diameter of nearly 5 millimeters. So in that small area, very small amount of light starting from a star reaches, and we are not having any sensation of vision. We cannot see that star. Now imagine that your eye was too big, this big, then you would have been able to see many more stars, because this big area would collect much more light energy from a distant star and you will have a sensation of vision. So that is telescope. A telescope has a big lens. You focus it towards some star and it captures a good amount of energy coming from a distant star and focuses it to your eye, and you have a sensation of vision. You see that star. Obviously, telescopes will never be good if there is lot of light pollution, if there is lot of atmospheric absorption. So most of the good observatories, good telescopes have been placed on top of a mountain so that light reaching from star do not suffer loss in energy due to lot of atmospheric absorption. Here in this slide you can see one such telescope which is mounted on a mountain, Mauna Kea, and it is there in Hawaii. Even better if we can place one telescope in space altogether, outside our atmosphere. Yes, that was done in year 1990. America has placed one telescope which is known as Hubble Space Telescope. It is just like a satellite going around the Earth, and it has got a very large lens. In fact, it is a reflecting type telescope. It captures a lot amount of light energy from distant galaxies and stars, and it gives us really nice pictures of galaxies and stars. In the slide, the third picture is picture of one galaxy captured by this Hubble Space Telescope. So telescope has helped us a lot in gaining knowledge about our universe. But still we are not satisfied with what we are having, and few countries have collaborated in making a really giant telescope. It is being built somewhere in South America in Atacama Desert. It is known as Giant Magellan Telescope, and it will get fully commissioned by year 2022. This telescope is going to have light encashment area of diameter more than 24 meter. More than 24 meter. 24 meter is roughly 100 feet, and it is nearly a building 9-story high. So the light encashment area is like a building which is 9 to 10-story high. So you can imagine how giant it is. And it is believed that it will make us see those stars which are even 13.5 billion light years away. You must be getting bored by now. Why is it necessary to see all these distant stars? What do we get by seeing all these distant stars? Why are we so obsessive of seeing a star as far as 13.5 billion light years away? Think carefully. Think carefully. You will be looking at your past. Yes, you will be looking at history of universe. How come? A star which is 13.5 billion light years away cannot give you light instantly. A light ray which started 13.5 billion years ago from that star is now reaching your eye, is now reaching your telescope. So whatever you are seeing is not the present position of the star. It is the position of the star 13.5 billion years ago. So you will be more or less seeing the universe as it was 13.5 billion years ago. That point is considered to be very close to Big Bang. It is widely assumed that Big Bang happened around 13.8 billion years ago. So what we will be seeing actually? We will be seeing how our universe looked immediately after Big Bang. That will help us in knowing our genesis, how actually this universe was created and things like that. So it is quite interesting to watch stars also. You can learn a lot about our genesis. Okay. This vastness of universe is quite fearsome also. When I was a kid like you, in year 1992, I heard on news channel BBC London that a comet named Shoemaker-Levy 9 was going to hit Jupiter. Actually, Shoemaker and Levy were two astronomers and they searched many comets. Shoemaker-Levy 9 was the ninth comet they searched. And they predicted that in next 2 years, this comet is going to hit the giant planet Jupiter. And it precisely happened that way. In the month of June 1994, this comet hit Jupiter. If you can see this diagram slide, there are few dark spots on the surface of the Jupiter. If you can see that carefully, few dark spots on the surface of the Jupiter. They are big craters which were created by the impact. And Jupiter is a giant planet, mind you. It appears as if it is a very small dot. Let me tell you, one of those dots is even bigger than Pacific Ocean. Yes, it is even bigger than Pacific Ocean. And these diagrams, these pictures have been captured by various telescopes. One such event happened in year 2009 also. That means a comet or an asteroid struck Jupiter, but it went unnoticed. Nobody knew that it is going to happen. Later on, when people found dark spots on the planet, they came to know that, okay, something has hit this giant planet. So what am I trying to tell you? I am trying to tell you, such massive giant object may hit us as well. Yes, some asteroid may, some comet may hit Earth. We may be able to observe that. We may not be able to catch that because universe is truly vast and it is just not possible to look at every nook and corner all the time. So some strange object may be headed towards us someday and it may hit us badly. Has it happened before also? Answer is yes. 6.65 million years ago, 6.5 crore years ago, one such object struck Earth somewhere in Mexico at a place known as Chicxulub, and it eliminated 70% of the species on the Earth. Mighty dinosaurs got eliminated because of that impact. More recently, in year 1908, somewhere in Siberia, such, I would say, rather small object struck Earth because it was an uninhabited place. I mean, there was not much of population in that place, so there was no casualty as such. But the place where it struck, from that place, draw a circle of radius 40 kilometer. In that entire area, all trees were simply burnt. This event is famously known as Tunguska explosion. Such thing might happen in future also. And if it happens, we do not have a sure way of saving ourselves. Some of you need to think on it, and some of you will in future come with a proper way of saving ourselves if such an object is headed towards Earth. This is all about vastness of the universe. On the other side, physics deals with something very tiny, something very minute to the scale of an electron, something as minute as an electron. In fact, vastness cannot be understood without knowing a lot about minuteness. You all know, I guess, that an atom is of the size of 10 to the power minus 10 meter. Its radius is 10 to the power minus 10 meter. And a nucleus is having a size of 10 to the power minus 15 meter. How small is that? How small actually is atom? A human hair, the diameter of a human hair is roughly 0.1 millimeter. 0.1 millimeter. If you take a hair strand and cut it longitudinally, divide it into 10 segments longitudinally, Each segment will have a diameter of 0.01 millimeter, that is 10 to the power minus 5 meter. Now one strand is almost invisible. If you take this one strand and divide it longitudinally once again into 10 segments, now the one strand is close to 10 to the power minus 6 meter. You have to repeat this process 4 more times, and then the thing that you are having will be having a diameter of an atom. A nucleus is even smaller. If a cricket field is an atom, then a peanut placed at the center of the field is a nucleus. And once again, the most amazing thing is, we know all these. Yes, physicists have been able to measure this, and they know all these things. That is the most amazing thing. Okay. In spite of all this, the fact remains that we know very little about our universe as well as the nature as a whole. Let me tell you that 95% of the universe is dark energy and dark matter. The name itself says that we know a very little about this dark matter and dark energy. And 95% of things are still to be discovered. That is what I am trying to tell you. Now, in the last segment of this webinar, I'll try to give you basic rules of learning, mastering physics, and general approach to solve problems, and then I'll give you some practical tips on how to tackle the JEE exam. Because of limited time, we could not explore more into the scope of physics. I tried my best to excite you in this subject, to make you feel excited about this subject by telling you about its scope a little bit. Let us move on to basic rules for mastering JEE physics. See, if you want to master physics, physics is considered to be one of the most difficult subjects, if I am not wrong. The first rule is love it. Once you start loving it, you will study it more, you will practice it more, and then definitely you will learn it. So for loving physics, I would suggest you should be in habit of reading not only your textbook, but variety of articles, journals, whatever you get related to the world of physics, you should try to read it. That will develop interest, and if you develop interest in physics, nobody is going to stop you. You will definitely learn it one day. No procrastination. That means no lagging behind. Physics is a subject which is in which all chapters are interlinked. They are interlinked to each other. Suppose in mechanics, someday your teacher is teaching rotational motion. If you have missed a couple of chapters before that, you will not be able to understand anything in rotational motion. So you need to remain up to date. You should not miss any class. And even if you miss some class due to some emergency, you must cover it up as soon as possible. No lagging behind is allowed in this subject. All topics are interrelated. Then no passivity. You cannot learn physics by attending lectures, taking down notes. No. You have to be active. What does it mean? When a teacher starts a derivation or when a teacher starts solving a problem, try thinking one step ahead of him. Try thinking what next, what will happen after this step. Try to do it on your own. If you actively do it, then only you will learn physics. It is learned only by way of actively doing. Passive listening will not help you learn this subject. And then no isolation. I mean, you should not try to learn physics all by yourself. You must discuss with your friends and teachers. Whichever problem you are not able to solve, whichever concept you are not able to understand, you must have a full-fledged discussion with your friends and your teachers. This is really an eye-opener. I have seen students doing exceedingly well who were always found discussing with their colleagues and teachers. Then of course practice a lot of problems, because stating Newton's three laws of motion is quite easy, but actually using it in problem is very difficult. You learn to use these laws only by practicing a lot. And one thing I have found is students getting obsessed with pattern based question. Because JEE is asking match the column type question or comprehension type question, you get obsessed with those type of questions, and you just think that by doing only match the column question, comprehension type question, you will be able to qualify in this exam. No, this is not true. For the sake of learning, you do not require any objective question. Objective question pattern has been introduced because there are 14 lakh aspirants, and humanly it is not possible to check copy of all of them if the exam is subjective. So objective pattern was introduced, but even if you read the syllabus or brochure of IIT JEE Advanced, it clearly says that this objective paper will maintain the subjectivity. That means questions in comprehension type, match the column types, they are being designed so that more or less they are subjective questions only. So while learning, you should focus more on subjective questions rather than objective ones. This is one big advice that I am giving you. Focus on subjective questions. Once you know physics, you will be able to solve every type of questions. Then while you are practicing problems in physics, what should be your methodology? First thing, before sitting down on your study table, always tell yourself what you are going to do in next 1 hour or so. This brings focus. When you say that I am going to solve 20 problems in current electricity from so and so book in next 1 or 1.5 hour, it brings focus. Now your mind will not divert. You know that you are going to attempt these questions in next 1.5 hour. So doing this really helps. If you don't do, then what will happen? You will study half an hour of physics, then you will close the book. You will study half an hour chemistry, you will close the book, and maybe you will study 15 minutes mathematics and then go to bed. So always know what you are going to do when you sit down on your study table. Never be in haste of doing number of questions in 1 hour or 2 hours. Don't time your questions. While learning physics, it is necessary to understand a question and a solution properly. It is not at all important. It is not at all important to solve hundreds of questions without proper understanding. Don't time your solution while learning. I mean, you should not keep a watch on your table while you are trying to solve a physics problem in your house. Give proper respect, give proper time to any particular question. Mostly you are tentative. You apply some method and it fails, you don't get the answer. You apply another method and you get the answer. You get excited, you feel happy, and you move on to next question. Don't do this. As soon as you get an answer to the question, stop there. Now start thinking why your earlier method has failed and now why this method is correct. You must very clearly understand what was wrong with your earlier method and what is exactly right in your new method. Focus on what works and what does not. You must tell yourself, in this kind of question, energy conservation works. In this kind of question, work energy theorem works. And you must know why energy conservation works here and why not work energy theorem. Why momentum conservation works in another question, whereas it does not work in next one. You must figure out such things, then only you will have a proper understanding. If possible, try to figure out alternative ways. Alternative ways means the entire solution may not be very drastically different from the one you have done right now. You can think how equation number 1 can be written in a different way. How equation number 2 can be written in a different way. Can there be a different approach altogether for getting equation number 3? Even alternative ways of doing parts of a problem are very meaningful. You must always try to find out alternative ways of doing problems. If you are stuck up badly in a physics question, you are not getting any clue where from to start, then let me tell you, try some conservation laws. Think in terms of law of conservation of energy, law of conservation of momentum, or law of conservation of angular momentum. Maybe you will be able to solve that problem. Conservation laws are your real best friends. In fact, any question for which you are not sure about the direction, always try with conservation laws. I am guaranteeing you some of them will definitely work. Now, let us come to some practical advice for JEE exam. First thing is, emotion does not help inside the exam hall. You should not be emotionally attached with one subject or one chapter. The students tend to believe that they are quite strong in chapter X or subject X, so they will do it first. And the weaker one is usually taken up later in the third hour of the exam. That is not the correct strategy. If you go to bat in a cricket match and you see that Brett Lee is coming to bowl to you, and you are afraid that, okay, Brett Lee is bowling, so how can I play? Definitely first ball you are going to get out because you are afraid of Brett Lee. No, don't see who is the bowler. Just see what kind of ball he is throwing to you. If it is an over-pitched ball, it is asking to be hit, whether it is Brett Lee or some other ordinary bowler. So if the ball is loose, if the delivery is loose, you definitely go and hit it hard. If the ball is good, even if it is not a famous bowler, you have to respect it, you have to defend it. Similarly, if question number 1 is not from your favorite subject, but it is very easy, you need to do it first. If question number 2 is from your favorite subject, but it is too hard, just leave it. So the wisest person inside the exam hall is not the one who does all the tough questions. He is the one who does all the easiest ones. So try to pick out easy questions inside the exam hall and solve them. That is the straightforward strategy that you have to follow. Don't go by subject, don't go by topic. Question number 1, is it easy? Will you be able to do it in first attempt? Do it. Question number 2, you think you will not be able to do, just leave it. Don't think twice about it. Question number 3, you find it too tough, just leave it. Question number 4, yes, you believe you can do it, do it. Do it, do it, do it. JEE is a low scoring exam. Even if you score 50% marks, you get a good rank. If you score 60-70% marks, you get very good rank. And if you score 90%, then you are definitely under top 10 or top 20 in India. So first do all the easy questions. If time is left to you, then try attempting the tough ones which you have already left. Even if you are able to do all the easy ones, I guarantee you will get a very good rank in JEE. And one more thing, too much of analysis and emphasis on statistics will not help. The students tend to believe that chapter X is very important, chapter Y is not so important. No, this is not the correct approach. You never know how many questions are going to be asked from chapter Y. Even if it is an easy chapter, believed to be an easy chapter, there may be a couple of questions from that. So don't disrespect any chapter just because it is easy. Prepare it well. If it is easy to you, you must prepare it well, because if any questions are asked from that chapter, you will definitely be able to do that. If a chapter appears very difficult to you, you just prepare at moderate level so that if easy questions are asked from that chapter, you are able to do it. But if there are really tough questions from that chapter, you are just going to leave it. Inside the exam hall, I have seen many a times problems on dimensional analysis surprises students. What does it mean? I'll just take a rough, easy example. Suppose the question is asking you to calculate some kind of force. And option 1 is 2 times of mg. M is mass, g is acceleration due to gravity. Option B is 3 times of mg. Option C is 3 by 2 times of mg. And option D is 0, let us say. Now, without solving this question, actually you cannot answer. All the options have dimension of force. Mg is force. So 3 by 2 mg or half of mg is force. But if options are somewhat like this, mg, mg square, m square g, m cube g, then obviously you need not solve this problem. Just by looking at the options, we know that answer has to be option A, because mg square cannot be force or m square g cannot be force. So such questions have been asked in JEE in past, and they have always surprised the students, because apparently those questions are very tough. In routine manner it is very difficult to solve them, but once you observe the options, you just get the answer by using dimensional analysis only. So beware of that. Dimensional analysis can really surprise you. In many questions, you can check for extremes and easily get the answer. It means if there are two masses in a particular system, there are two blocks having mass capital M and small m, and suppose you find that the solution is quite lengthy, you can look at the options and try to judge what will be the answer to the question if a small mass m is 0. One of the blocks do not have any mass. Think like that. Now, what will be your answer if one of the block is massless? Does any of the given options A, B and C, D satisfies to what you understand as to be the answer when m is 0? By checking A, B, C, D given options for such extremes, many a times you will be able to solve problem. You can check what will happen if the mass m is infinite. What could be the answer if one of the mass is infinite? You look at the options A, B, C and D. Which one satisfies your guess? If option A satisfies your guess, that has to be the answer. Every year, I guess, 1 or 2 questions are there which can be used using this method, which can be solved using this method. But never do this while you are learning at your house. Always try to have a proper solution when you are learning at your house. These are tricks and tips which you can use in exam hall. Convert 3D diagrams into 2D. Many a times I have found in JEE advanced paper, they draw a really fearsome diagram. They give a diagram in 3 dimensions, and that really makes you crazy. Whenever you see a 3-dimensional diagram, think how you can get it converted into a 2-dimensional diagram. For example, if it is a question on motion of charged particle in electromagnetic field, then always try to have magnetic field pointing perpendicular to the surface of your notebook. Take magnetic field perpendicular to surface of your notebook and then draw the diagram. So similar strategies can be used elsewhere also. If it is a 3-dimensional wedge and a block has been placed on it, you are used to drawing a 2-dimensional drawing. You need to understand how to convert that 3-dimensional drawing into a 2-dimensional one, simplified one. So many a times a 3-dimensional drawing can surprise you. Be patient, try to convert it into 2D diagram, and then you will be able to solve it. These days many comprehension type questions are asked in JEE, and few of them are quite lengthy. A page of write-up, and that appears to be out of syllabus. A page of write-up that appears to be out of syllabus, and there are 2-3 questions on that. The students usually get afraid of such questions. There is no reason to be afraid. Just read the given passage carefully. Most probably all 2 questions have answers written in that passage itself. You have to read that carefully, have confidence in you, and you will be able to solve it. In fact, I can guarantee that it will not require much of mathematics and much of prior knowledge of physics as such, because it is out of syllabus. So whatever required is given in that paragraph itself. So don't be afraid of such questions. Read them carefully. You will be able to answer them. Now students usually complain to me regarding their inability to do more than one correct type questions. There are 4 alternatives are given, A, B, C and D, and 1 or 2 or 3 or even 4 of them are correct. So how to tackle those questions? See, you have to understand that this is actually 4 different questions of true and false type, which has been asked as one single question. After reading option A, you have to take a firm decision whether it is true or false. If you have decided that option A is true, then you are not going to change it after reading option B. We tend to do this mistake. We have decided that option A is true. We go to option B, feel confused, and then change our response to A. No, this is not done. Do not do this. Read option A, decide whether it is true or false. Do you know whether it is true or false? If you do not know whether it is true or false, then why read option B or C or D? Just forget about the question. If you are very sure that yes, option A is true or false, then read option B. After reading option B, don't change your response to A. After reading option B, decide whether it is true or false in the context of the question. If you know for sure that it is true or false, then move on to C. If you are confused, you do not know whether B is true or false, then forget about the question once again, leave it then and there. Save your time, precious time. Then C, then D, and this is what you have to do. You have to read one option at a time and treat each one of them to be independent of other 3. Similar thing is there with match the column type questions. There are 2 columns, A, B, C, D and P, Q, R, S. Read option A, then read P, Q, R, S. With option A, read P. Is it true or false? Decide there. Q, option A with Q. Is it true? R, option A with R. Is it true? Option A with S. Is it true? You have to decide whether what is the answer to these 4 true false type questions. Then option B, take it with P, Q, R and S. Then next one, same thing repeated. Go on doing like this and never change your response, earlier response, after reading the next one. This is a genuine advice. Try to follow this. Most of the time we commit this mistake that we change our answers after reading other options. I hope I have given you enough of good advice and it will help you in scoring well in JEE. With this view only, I have authored 2 books for problems in JEE and which are fully solved. I hope those 2 books will be beneficial to you also. Thank you and आप सभी को मेरा नमस्कार.